is my home. I promise to keep it healthy and beautiful. I will love the land, the air, the water, and all living creatures. I will be a defender of my planet, united with friends. I will save the earth.
The Metropolitan Water Reclamation District of Greater Chicago is one of the largest and most efficient wastewater treatment agencies in the world. They treat and dispose wastewater for more than 5.4 million residents of the city of Chicago and 124 adjacent communities, as well as an industrial and commercial load equivalent of another 4.5 million people. The Stickney Water Reclamation Plant is the largest wastewater treatment facility in the world. The plant serves 2.38 million people in a 260 square mile area, including the central part of Chicago and 43 suburban communities. The Stickney treatment plant mimics the purification process that occurs naturally in rivers and streams, condensing what would take 1 or 2 weeks to just under 8 hours. The Stickney plant has a design capacity of 1,200 million gallons per day. Stickney actually consists of 2 plants, the west side portion of the plant, which was placed into service in 1930, and the southwest portion of the plant, which was placed into service in 1939. The west side portion of Stickney was first constructed in 1930 and deals with 40% of the primary treatment of the incoming wastewater. The southwestern portion was constructed in 1939 and provides both primary and secondary treatment. It treats the remaining 60% of the incoming wastewater. It also serves as the secondary treatment for the wastewater from the west side portion. The tour of the plant begins in the administration building, housing the main control room and laboratories that oversee the entire plant. Plant operators and technicians keep track of all the Stickney plant facilities and operations every day. There's always someone monitoring the plants at all times. The latest computers keep track of all the facilities to make sure they are all working properly. If a machine is damaged or malfunctioning, engineers can be notified and be sent to fix the problem. Technicians also keep a constant watch of the weather so that they can make adjustments to control how much water is entering and exiting the plant.
My name is Commissioner Frank Avila. I'm a commissioner at the Metropolitan Water Reclamation District of Greater Chicago. We cover all of Cook County in Illinois, and our 3 missions, we have 3 missions at the Metropolitan Water Reclamation District of Greater Chicago. Our first mission is protect our water supply, which is Lake Michigan. And because we need water to live, and we want to make sure that nothing is polluting our water supply, which is Lake Michigan. Our second mission is we try and manage flooding here in Cook County. And our third mission, and that's where most of our dollars go to, is that we treat wastewater. And they all say, what is wastewater? Well, have you ever heard the 2 peas in the pot? Well, we treat poop and pee. We treat the storm water when it rains and hits the ground and goes into a control system, which is a local source. And we also treat the industrial waste. And we have 7 plants here in Cook County. And one of the plants, Stickney, is the largest plant in the world, and right now we're here at the Stickney plant, and we're going to give a tour. And Casey Nesbin, which is our tour person, will explain all about the Stickney plant. And don't forget, it's the largest plant in the world. We treat up to 1.4 billion gallons of wastewater a day. And I explain what is wastewater. Again, wastewater is the two P's in the pot, poop and pee, all the industrial waste that comes into our system. And when it rains, the storm water also that comes in our system. And if you wash your dishes, if you take a bath, that also comes into the system. So what a person does throughout the day comes into our system, and this is Stickney, the largest plant in the world. And also I have here one of our top engineers, our top civil engineers at the district, Joseph Cummings. He's been here a lifetime, huh, Joe?
It feels like that, 16 years.
16 years. And
16 great years.
And Joe is one of our top civil engineers. We are the expert in treating the two P's in the pot, poop and pee. Now I'm going to turn it over to Casey Nesbin, and she's going to explain about the tour here at Stickney.
Thank you, Commissioner Avila. And again, welcome to the world's largest wastewater treatment plant, the Stickney Water Reclamation Plant. First, I'm going to take you over so that you can see our main control center, where our treatment plant operators monitor what's going on in the plant. So this room right here is called our main control center. The individuals working in there are called treatment plant operators, or TPOs. We just use the acronym. They monitor the levels of the sewage entering the plant. You can see computer monitors are being projected onto a board. They're constantly monitoring the equipment that's running in the plant, if any gates or any valves need to be opened or closed, if we need to turn on any other plants. They also monitor the oxygen found within our aeration tanks, and as well as the oxygen in our aerated grit tanks. If you look to the right, underneath the clock, underneath the clock, you will see that there is a board with the online weather station. They are monitoring the weather approaching the Chicagoland area. If we are to get storms or bad weather, they will be the first to know, and they will adjust the way that the plant is running accordingly.
Casey, you mentioned about the oxygen, is that as a human being, we need oxygen to breathe and live, right, Casey? Where the aquatic life in the waterways need dissolved oxygen. So they got to make sure they maintain the proper oxygen in the waterways, because that determines the quality of the water in the waterways here in the Chicago area waterways.
That's correct, Commissioner. Okay, and now we're going to go over. Okay, now we're going to look at this aerial photograph of the Stickney Water Reclamation Plant. The Stickney plant is actually comprised of two smaller plants. The first plant was completed in 1930 and is considered the West Side plant. This plant provides primary treatment to about 40% of the incoming wastewater. After the primary treatment, the wastewater then is sent over to our Southwest plant, which was completed in 1939. This plant provides both primary and secondary treatment. It treats about the remaining 60% of the wastewater entering the plant. It also provides the secondary treatment for the 40% wastewater that's coming over from the West Side plant. The entire plant sits on about 570 acres of land.
You mentioned the plant covers 570 acres of area of plant, and don't forget, 1 square mile is 640 acres. So this is almost 1 square mile of plant operation here at the Stickney plant. And don't forget, as Casey mentioned, this is the largest plant in the world. And every day we take care of 5 million people here in Cook County. And every day, 24 hours a day, someone is eating and drinking. And this plant operates 24 hours a day also. And so we're protecting the health and welfare of the people here in Cook County. Don't forget, when you eat and drink, we take care of the two P's in the pot, your poop and pee, when you eliminate your waste.
Now we're going to go over to this diagram to explain exactly what we do here at the Stickney plant. So now we are here at our down the drain diagram to give you a description of what we do here at the Stickney Water Reclamation Plant. In the Chicagoland area, there are two types of sewer systems. You have the separate sewer system, where the sewage from the homes will come directly to the water reclamation plant, and the sewage from the street, the storm runoff, would go into our local waterways. However, here at this district, we want to capture as much sewage as possible to treat it before we put it back into our local waterways. So we have our combined sewer systems, which captures the sewage from the homes and businesses as well as the street. And we bring it here to the Stickney Water Reclamation Plant. We treat it and then we dump it back into our local waterway. However, if it rains a lot or if it floods, we have what we call the deep tunnel, which is first of its kind design in Chicago to capture the overflow and transport it to the reclamation plant. The deep tunnel that serves the Stickney Water Reclamation Plant is called the mainstream tunnel, or we call it TARP. The first set of tanks that our sewage water will enter is called the aerated grit tanks. In these tanks, you will find a chain conveyor system with wooden boards. The purpose of these tanks, the sewage water enters, and although we capture debris in the coarse screens, there's still some small debris that got through. So we're blowing air into these tanks to cause the sewage to churn and to move around because we want to get the grit and the solids to drop to the bottom. As it drops to the bottom of the tank is sloped so that the grit and solids will make its way into a little channel where we have our conveyor system with wooden boards turning very slowly to push the grit and the solids into a drain. That drain would then exit out into a truck, which we would take the grit and solids out to a landfill. Again, we do not treat the debris here at the Stickney plant. After the sewage passes through the aerated grit tanks, it next goes into our primary settling tanks. Key word is settling. We want the sewage to settle. We want the lighter debris, the floating fats and oils to lift to the top and sit on top of the water. And then we want the solids and the grits that we still have in the sewage to drop to the bottom. Again, we have wooden planks on a turning system pushing the floating fats and oils into a drain at one end of the tank. And at the bottom, the same thing is happening where you have the solids and the grits being pushed to the drain, pushed into a drain, and being pushed into a drain at the other end of the tank. At this time, the solids are now being sent over to our solids treatment side to be turned into biosolids. After about 45 minutes, the sewage will then pass on to our aeration tanks. In these tanks, we have our activated sludge microorganisms. These microorganisms are essentially good bacteria that's eating away at the bad bacteria. But as we stated earlier, we have to blow air or oxygen into these tanks because like you and I, we need air to live and breathe. So do these microorganisms. So the microorganisms are found in these tanks living, eating away at the bad bacteria. The bad bacteria breaks down and the components drop to the bottom. At this time, those components are called waste-activated sludge, and that's being sent over to our solids treatment side to be turned into biosolids as well. After 6.5 hours, the sewage will then pass into our final step in the treatment process called the final settling tanks. These tanks are similar to the primary settling tanks in that we're still wanting the water, the sewage to separate. We want the solids, any grit that's left in the sewage, we want that to drop to the bottom. In these tanks, you will find a mechanical arm turning, and at the bottom of the arm, there's a brush. This brush sweeps the bottom of the tank, and any solids found in this tank is then pushed into a drain. This drain, the solids found in there is now called reactivated sludge. That sludge, reactivated sludge, sent back to the aeration tanks to be treated again. After 2.5 hours, the sewage is then dumped into our final conduit tank. It is 95% treated, and it makes its way through a series of pipes and conduit to where it goes through the outfall into the sanitary and ship canal. The entire wastewater treatment process takes approximately 12 hours.
That's excellent, Casey. And you know what Casey was saying here on this activated sludge where you have your microorganism is that our body also, when we eat, we have a little digestive system. And the reason why we stay healthy is because we have the good microorganism overtaking the bad microorganism, and it works the same way here. And that's why the quality of the way we treat our wastewater depends on our good bugs, the good microorganisms, and that's why we have to make sure that they stay in the system. And a portion of that will go out of the system, and she called it biosolids. And so after the treatment, it's because we're so intelligent and high class, the treated poop now is called biosolids.
Okay, so now we're going to discuss the solids treatment process, where we produce our biosolids. So as I stated, we have sludge coming from our primary settling tanks, waste activated sludge coming from our aeration tanks, going over to our concentration tanks to be turned into biosolids. The first set of tanks, as I stated, are called the concentration tanks. The sludge will sit in these tanks approximately 4.5 hours. Essentially what's happening is we want the sludge to settle to the bottom, we want the water to lift to the top. The water is drained off, and the sludge continues through the solids treatment process. Goes into our first set of centrifuges. The centrifuges rapidly spin to extract more liquid from the solids. It's similar to a spin cycle on a washing machine. The washing machine spins real fast to remove as much water as possible from the clothes. After a 5 to 7 minute spin cycle, the sludge will then go into our digesters. We have 16 digesters which cook the sludge at 95 degrees Fahrenheit. However, also in these digesters, you will find the microorganisms that were also in our aeration tanks. These microorganisms are, again, eating away at the bad bugs. These are the good bugs eating away at the bad bugs, trying to get as much bad bacteria out of the sludge. After 28 days of being cooked at 95 degrees Fahrenheit, the sludge then enters the last step in the solids treatment process, our final centrifuges. Same system as before, goes through a rapidly spin cycle to extract more liquid from the solids. After 5 to 7 minutes in the centrifuge, it is then lowered into our rail cars, where it's now 65% solids, and it is sent out to our Lawndale Avenue Solids Management Area, also known as LASMA, whereas then it's sold to different agencies to be used as fertilizer for farming, golf courses, or schoolyards.
Excellent, Casey. And now, Casey, at the district, what we're doing now, we're going to use, and we used to call it wastewater, but it's not wastewater anymore, because what we're going to do is that we're going to use that the people's waste, the 2 peas in the pot, as I mentioned, that in the digester now, right up here in the digester, we have a lot of gas in that digester, and that's methane gas, and we're going to convert that gas to energy, and we are going to save the taxpayers some dollars, because we're going to recapture that gas, convert it to energy, and then use all that energy to power all of our plants, and we're going to try and do this in about 10 years. So we are going to save the taxpayers about $30 million in converting your gas that you give us every day, the methane gas, to energy. Also, what we're going to do is in your urine, we're going to capture the phosphorus that is, they say, has been a depleting item here in the world. We're going to capture that phosphorus, and we're going to sell that phosphorus on the market, and that'd be the phosphorus removal plant here in Stickney, which is going to be considered the largest phosphorus recovery system in the world. So Stickney, as I mentioned, is the largest wastewater plant in the world that treats your 2 peas in the pot, poop and pee. We're going to have the methane gas, convert that to energy, and also Stickney is going to be the largest phosphorus recovery plant in the world also. We are doing amazing things here at the Stickney plant, and Casey and Joe Cummings are the expert in treating your 2 peas in the pot. At the Stickney, at the Water Reclamation District of Greater Chicago, we are the expert in treating the 2 peas in the pot.
Okay, so now we're going to actually go into the plant and see some of these structures and tanks that we just discussed in this diagram. The first stop will be the pump and blower building, where we will see the 6 huge main sewage pumps as well as the blowers that lift the sewage water after it enters the plant 40 feet beneath ground level.
As tours make their way to the pump and blower building, visitors can see the final settling tanks and the aeration tanks that are in operation, as well as many construction projects that are happening at the Stickney plant. The pump and blower building contains the main sewage pumps that lift sewage from the incoming sewers to an elevation that allows gravity flow to the rest of the plant. This is also the building that contains the blowers that supply the compressed air to the aeration tanks.
This is our first, this is grit chamber here. Why is this grit chamber? Because this is removing all the grit, the sand, the gravel, any.
What, yep. Yeah, we'll hop out right here.
The second stop on the tour is the grit chamber. The sewage flows through aerated channels at a slower velocity than it does in sewers. Because of the slower spiral flow, heavier inert materials such as cinders, sand, eggshells, and other smaller waste settle out. This material is pumped out and disposed of in private landfills. Because of the frequent use of these machines, they have to be regularly maintained in order to function properly. At the Stickney plant, various porta-john companies dump wastewater into the grit chamber where it can be properly treated.
Joe Cummings, I'm with Joe Cummings, and we're at the first stage or the second stage of the wastewater treatment process, and this is the grit chamber, right, Joe?
Right, this is an aerated grit chamber. What's happening in the aerated grit chamber is the grit, the concrete chunks, rocks settle to the bottom, and then the flights, chain in flight, a mechanism is going to come and push it to the bottom to collect it to go off to a landfill. What we wanted to point out while we're here, this truck behind us, this is a waste hauler truck. Just like you have porta-johns out at your sporting events in the parking lots or in your parks, and these trucks will collect all the sewage that's inside the porta-john. They collect it and they have a permit to come and discharge directly into our process for further treatment.
So do you see the discharge now from the truck? Let's walk over here, and you could film the discharge now. And as Joe mentioned, now what's going on right now, Joe, in around the Chicagoland area?
Well, there's always a porta-john somewhere. You drive out in the public, you're going to see it somewhere. What we've got coming on this weekend, the Lollapalooza Festival will be in Chicago, and we'll have these trucks running probably 24 hours a day because it's such a large festival. But anytime you have Taste of Chicago, or even if you go to your neighborhood park and there's no public washroom, there's a porta-john. It's got to be collected and it's got to be treated somewhere.
And this is where the trucks here will come in and discharge their the 2 peas in the pot right here in the grid chamber.
This is where the heavier decomposable solids are settled out of the raw sewage. These tanks hold the sewage in a relatively quiescent condition for a period of time to allow settling. Approximately 20% of the oxygen requirements in suspended solids, which are impurities in the sewage, are removed here in the form of preliminary sludge. This sludge is then pumped into the concentration tanks.
These are our primary settling tanks. The sewage will sit in these tanks approximately 2.5 hours. We want the lighter stuff to float to the top, like floating fats, oils, scum. As you can see, it's sitting on top of the water. It's light. At the same time, we have this heavier debris dropping to the bottom. You can see this board right here is about to turn under. What happens is these boards will move through the tanks to the left, pushing the bad stuff on top into the channel down here to our left. As you can see, that board is going down because it's pushing that floating fats and oils further into this channel over here. The same thing is happening on the bottom where the solids are being pushed into a drain at the opposite end of the tank.
These are the final settling tanks. This is where the mixed liquor from the aeration tanks is held in a quiescent condition to allow settling of the flock. The sludge which settles here is pumped back to be mixed with the incoming sewage at the beginning of the aeration tanks. Part of the sludge from the final tanks, which is excess cellular material, is split off the return sludge and wasted to the concentrated tanks. The overflow of the final tanks is the reclaimed water. Small animals such as goldfish can be found in the final settling tanks. The final effluent is discharged into the Chicago Sanitary and Ship Canal, which flows into the Des Plaines River. These are the aeration tanks. In these long tanks, biological treatment takes place. A brown substance called return-activated sludge, which is composed of bacteria, uses the organic materials that remain in the sewage after preliminary refining for food. Thus, the bacteria cleans the water by using some of the organic materials for energy to live on and by converting the remaining materials to additional cells. When converted, the previously unsettleable and dissolved organic material can be settled in the form of a flock. The portion used for energy is broken down mostly into water, carbon dioxide, and nitrate. The air from the blowers is needed because the bacteria require oxygen for respiration. Bubbling the air mixture of sewage and sludge called mixed liquor provides this oxygen while agitating the mixture to keep the solids in suspension.
So the tanks you see to my left, those are aeration tanks. That's where we have our microorganisms living. You can see the bubbles, that's from the air being blown into the tanks. As we stated earlier, the microorganisms need air just like you and I to live. So the sewage water was sitting in those tanks about 6.5 hours with the microorganisms eating away at the bad bugs. After 6.5 hours, the sewage water would then pass over into our final settling tanks behind us. It would sit in these tanks for 2 to 2.5 hours where it's going through a settling process. Again, we have the heavier solids dropping to the bottom, the sludge at this point, and then we have the cleaner water exiting out into this conduit in front of us, which is called the final conduit. After 2.5 hours, it dumps into this final conduit where eventually it makes its way to the back of the plant and exits the plant through our outfall into the sanitary and ship canal. As you can see, we have fish in the final conduit. This water is now 95% treated. This is the final step in the water treatment process, which takes approximately 12 hours. The solids that drop to the bottom of the final settling tanks is now called reactivated sludge. We capture that sludge and we send it back through our aeration tanks. This is the reactivated sludge conduit over here. That sludge is then entered back into our aeration tanks to capture the good microorganisms so that it can continue to process.
And it's very important to reintroduce the good microorganism. Yes. Because we need the good microorganisms to continue cleaning the process of how we treat wastewater.
Yes, that is correct.
And, you know, it's just like, as I mentioned, in our body. When we eat food, we have to have the good microorganism to overtake the bad microorganism to stay healthy. Yes. Yeah, in our digestive system. Yes. Thank you very much, Casey.
Thank you.
Joe, do you have anything to explain here besides what Casey mentioned? She mentioned about the aeration tank. She mentioned about the finally settling tank, and she mentioned how we introduced, how you guys introduced microorganism again to be used again.
Right, I think you covered all the major points of it. The important thing is that the bacteria that we're using to metabolize all the wastes that are in the wastewater are naturally occurring, but they don't occur in the population, the quantity that you need to consume that much waste. So what you see here are the airlifts. We're lifting the solids that are coming from the bottom of the final tanks, lifting them back up so that they can be reused back in the aeration tanks and go through it all over again.
And as I mentioned, Stickney is the largest plant in the world. Our people here at the Metropolitan Water Reclamation District of Greater Chicago are the expert in treating the two P's in the pot, poop and pee. We have people from all over the world come and see how we protect the health and welfare of the residents of Cook County. Started here in 1962. I put in the interceptor, so we did the outfall, and it wasn't like this. It wasn't like this. Over 50 years, long time. I was a young kid.
Were you that young?
Yeah, I was, yeah. I think I was 22 years old. Just market.
This is the coarse screen chamber. The coarse screen removes large materials such as timber, plastic, and garbage from the incoming sewage. The garbage gets collected and sent off to be properly disposed of.
we're here at the west side. This is a fine screen. What you can see is a series of bars spaced about 3/4 of an inch apart, 3/4 inch gap. The wastewater is flowing through the bars, and any of the material that's in there, you'll see in a second a piece of paper getting stuck on the screen. That piece of paper is stuck, and then in a few minutes there is a rake that will go down to the bottom and scrape up all the material that is stuck on the fine screen, and it will lift it up, dump it on a series of conveyor belts, where it's then put in a dumpster and carried off to a landfill.
At what point of the process
Anaerobic digestion, a simple process, can greatly reduce the amount of organic matter which might otherwise be destined to be dumped in waterways, dumped in landfills, or burnt in incinerators which harm the environment. Solids are broken down by microorganisms, which produce gas in the process. The gas heats the digester to 95 degrees, which is the optimum temperature for the microorganisms. After the solids leave the last centrifuge, they have a solid-like texture. They still have a water content of 75% and need further treatment. They are transported by train to the Lawndale Avenue Solids Management Area. The biosolids are spread out so the water can evaporate, ending the process with 60% to 70% solids. They are then used for farms, landfill covers, golf courses, highway shoulders, and playing fields.
So what we have here, we have some of our post-digestion centrifuges. The solids that were produced in other processes come here for dewatering. They go through a spinning action, as Casey described earlier. All the solids that come out drop down to the bottom onto a conveyor belt system. Those solids, some of them go on to further processing and then will be treated as a beneficial product, as fertilizer that can go to golf courses, farms, and further sites, so that the solids are actually reused. They do not just go to a landfill.
Lunchtime, you ever lunch too? Oh, look at pizza. I got.
We just talk about it. Pizza's not part of the deal.
Daniel, this is the control room for the biosolids being dumped into the train, and then you can look out there going down.
We're all done there waiting for you.
How you doing? Mm-hmm. Doing okay? Mm-hmm. Yep.
Hey, how are you?
Good, how are you?
All right. We just see the final product. Yeah. We kind of close us on the final product. Oh. We don't go into the
But you, I didn't even think that you would come out to.
Yeah, we just ride past everything and then we come
So eating that must have eventually got tired of.
well, Reed told at first.
This greenhouse is where Metropolitan Water Reclamation District scientists and botanists use biosolids to grow various plants.
This is the green room at the Stickney plant, and this is where they do all their research on the use of biosolids on different plants. And they do some very important research here. And we have Dr. Pauline, which is one of the persons here that does a lot of the research. And as you could see, we have different plants here doing the research, and they're using maybe 100% biosolids or treated poop or a mixture of the biosolid. Now, Pauline, what type of plants do you have here in the green room? Pauline? Several species?
Different types. We've got ornamentals, we've got turf grasses, we've got herbs, we've got there's a rubber over there, which is a perennial.
Rubber? Now your turf grass is on the other side here, and what's your mixture on the turf grass?
No, you
The
mean
mixture of the biosolid, is it 100%?
No, we've got a blend of topsoil and sand, and then we got a blend of topsoil. I'm sorry, a blend of topsoil and sand, and then a blend of biosolids and sand.
Oh, I see. So here's our turf research here, and Dr. Pauly said she has a mixture of topsoil and sand and biosolid and sand, and they're doing the research, see which grows better, and this is a turf research here, turf soil here. And here's some more. Let's go to Dr. Pauly. Now, Dr. Pauly, what's in here? What type of plants are in here?
Okay, these.
Go on.
We've got it's a mixture. Okay, we've got various species.
Various species.
We've got pairs of pots.
Biosolids are the stabilized and dried organic matter that is settled out of wastewater in the treatment process. A sustainable alternative to chemical fertilizers, biosolids are used for landscaping and turf grass throughout Cook County. Biosolids co-composted with yard waste and other vegetation produce a high-value topsoil substitute. Biosolids return to the soil the carbon, phosphorus, nitrogen, and micronutrients that plants need to thrive. The purpose of the greenhouse is for the botanists and scientists to research and discover how the biosolids benefit the many plants that grow in the Chicago area. After collecting and treating the Chicago region's unwanted matter that's been poured down the drain, flushed down the toilet, or washed into storm drains for 125 years, the Metropolitan Water Reclamation District of Greater Chicago is embracing a new way of looking at sewage, not as a waste material to be disposed of, but as a collection of resources to be recovered and reused. Phosphorus is a non-renewable resource needed for life to exist. However, too much phosphorus in the environment can impair water quality and harm aquatic life. To meet new phosphorus limits, the Metropolitan Water Reclamation District of Greater Chicago is assisting industrial users in reducing phosphorus from their waste streams, while at the same time implementing plans to recover this sustainable resource. One way that MWRD protects the environment is by monitoring industrial discharges. As part of the strategy to reduce phosphorus levels, the MWRD asked commercial and industrial users throughout Cook County to evaluate their existing processes and identify potential opportunities to voluntarily reduce the phosphorus load in their discharge. Presently, two of the largest industrial users to voluntarily modify their processes to minimize the release of excess phosphorus are located in the Calumet plant service area. AgriFine Corp., a manufacturer of animal feed, and Gelita USA Incorporated, a gelatin manufacturer, have begun to pursue modifications in their internal processes. Although this effort is still in the early stages, these companies are to be commended for being proactive in addressing this critical water quality issue. In addition to providing technical assistance with managing internal processes, the MWRD staff can help organizations identify how they may be able to divert their high-strength waste phosphorus to a new recovery system that will be constructed at the Stickney Water Reclamation plant next year. The new facility will be the largest phosphorus recovery facility in the world, generating a magnesium ammonium phosphate slow-release fertilizer product. The process will transform phosphorus and nitrogen recovered from municipal and industrial wastewater into a high-value, eco-friendly fertilizer. The digesters at the Stickney plant produce biogas. Biogas consists of methane and carbon dioxide and is a product by the anaerobic digestion process that produces biosolids. The plant currently recovers biogas to heat plants. Biogas can be cleaned to natural gas quality compressed for vehicle fuel or combusted to produce steam or electricity. In the future, carbon dioxide could be recovered for industrial uses or accelerating photosynthesis in greenhouses. In 2014, the district will issue a request for proposal for methane utilization at the Stickney plant. Currently, the methane generated in the solids processing operation produce roughly 30% of Stickney's energy needs. This project will increase the efficiency of gas utilization such that Stickney will generate roughly 60% of the plant's energy needs. Currently, the Stickney plant uses Imhoff tank technology for primary treatment of roughly half of the wastewater flow into the Stickney plant. The Imhoff tank is a primary treatment technology for raw wastewater, designed for solid-liquid separation and digestion of the settled sludge. It consists of a V-shaped settling compartment above a tapering sludge digestion chamber with gas vents. In the digestion chamber, the settled solids are anaerobically digested, creating biogas. The gas is deflected by baffles to the gas vent channels to prevent it from disturbing the settling process. The Imhoff tank technology is original to the plant, placed in service in 1930. The Imhoff process will be replaced with more efficient primary tanks under the Capital Improvement Project contract, which is currently up for bid. This project will increase the amount of biogas produced at Stickney by roughly 40% because of the manner in which the solids are handled. The Stickney Water Reclamation Plant is the largest wastewater treatment facility in the world, mimicking the purification process necessary to clean our water supply in Cook County. In addition to treating our water, the top scientists, technicians, botanists, engineers, and workers come up with ways to make the Stickney plant cleaner and more efficient in treating our wastewater and producing biosolids that benefit our plants and wildlife. The commissioners, engineers, workers, and people of the Metropolitan Water Reclamation District of Greater Chicago continue their goal to keep our water supply healthy and clean.